All right, we're going to do a scatterplot, correlation, that kind of thing in Excel. A lot faster than doing it by hand, I guarantee you. So think of these as pairs of data, right? These are coordinates now. They create a point on a graph. So at 110 on the x-axis, it would you go up to 51 on the y-axis, and that would be a point. So that's how that works. So, but how you put in a scatter plot is you highlight the data first, go to Insert. There is the scatter plot right there, but I always go to Recommended Charts to see what Mr. Computer says, and it's usually right. So there's our chart title. We click OK. There's our scatter plot chart title. Let's fix that right now. We'll just put temperature and ice cream. Hold on. And we're going to see if they're related. So again, each point here is a coordinate from over here. That's how this was graphed. So to put a best fit line in there, you simply put your cursor over any point until you get that series 1 point, blah, blah, blah. You right click. I'll say that again, right click. You get this selection column. You're going to go to add a trend line. And give me a second. I'm going to pull over the important stuff that just popped up that you guys can't see. And there it is. This is what happens when you click Add Trend Line. So it should be preset to linear. We always assume a linear relationship. And down here on the very bottom, let me see if I can't get this for you. You want to click Display the Equation on the chart and display R squared value on chart. And then once that's up there, you simply click anywhere out. Click the X. Now what I do is always move the regression equation, the equation to the straight line, right? Remember y equals mx plus b. That's that line right there. That's the best calculated line, least squares of regression. And the R squared tells you the strength of the relationship between the two variables. And R squared of 0.01 means there is a very weak relationship here. In other words, the temperature is not controlling ice cream sales. You would think it would, but according to the data, it's not. So again, to answer all the questions, there is the scatter plot. There is the best fit line. There's the equation to the best fit line. We even have an additional R squared, which tells us that this is a very weak and positive, because it's a positive number, weak positive relationship. And in regular English, it would be the relationship between temperature and ice cream sales is practically zero. So in other words, when one value changes, the other one doesn't necessarily change with it. Okay, think cause and effect, but it's not really cause and effect. In other words, there's a lot of other things that could go into ice cream sales. First thing that pops in my mind is money. If you don't have any money, you can't buy any ice cream. No money, no honey. Ain't that sad but true. All right, next problem. We're going to build a correlational table using Excel. Click on the bottom tab down there. We want to see if people who do well on chemistry scores, right? These are scores of 11th graders. We're going to see who's related to who. In other words, do people that do well in chemistry do well in English? Do people that do well in chemistry do well in history, et cetera, et cetera? Chemistry and math, chemistry and political science. So we have a ton of different correlations to run here at the same time. So it makes sense to do what we call a correlation table, correlational table. And it's a lot easier than you think. Okay, so this is going to be a new approach. On your Excel, you're going to go to Data, the Data tab up at the top, Data, and if you don't already have a Data Analysis tab up here, you're going to add one. They're free. So if you don't have this here, you're going to go here to File, down to Options. You're going to go to Add-ins. And they should already be highlighted. You want the Analysis Tool Pack. Okay, you want that one. And then click Go. Very important, click Go. Do not click OK. No, go to Go. And normally they're all packed up for you. You really don't need this solver. That's for a different class. But these two are already pre-checked. Just click OK. And that should have put this data analysis tab on your thing. That should work. I don't know about Macs, but sorry about that. Okay, So in other words, here we go. We're going to start again. We want a correlational table to see who's related to whom. We go to the Data tab, Data Analysis. And up here are all your analysis tools. Look at all this thing. Oh, look at all this stuff Excel does. It's almost as good as SPSS. So we want correlation. Click correlation. Click OK. And it's asking you where's the input range. Okay, so what I do is just delete that. You can never trust it anyway. And with the cursor blinking in the box here, highlight everything, including the titles, all the data. And then you're going to click this box right here. It says labels in the first row. Go ahead and click it. And the output range, this is where you want the table to go. So again, with the cursor blinking in there, just pick any cell, any cell. I like to put them on the same one. Click OK. And here is our correlational matrix or box or whatever you want to call it. You'll notice right off the bat that you have a diagonal of ones. Don't worry about it because they're repeats, right? Chemistry correlated with itself should be perfect 1. English with itself is a perfect 1. Any variable correlated with itself is always a perfect 1. But now let's go to town. So here's chemistry and English. 0.005, weak, no relationship. History and chemistry, negative 0.07. Again, basically no relationship even though it's negative. Math and chemistry, very high. So in other words, people that are good in math are also good in chemistry. Political science, let's open that up a little bit. Political science, that's pretty strong for a correlation. So strength of correlation is 1 is weak, 0.1 is weak, 0.3 is medium, and 0.5 is strong. Anything above 0.5 is really strong. Okay, so you got chemistry people and math people. Here's kind of one. There's kind of, it's a medium. So you got English and history. People that are good in English are also good in history. And that's about it. Those are the only ones I see that are significant. All right, so to wrap this up is, here's the correlational table. And the big relationships are chemistry scores and math scores. And to a lesser degree, English and history. So that's it. Hope this helps. MGZ out.